Okay, now for this problem, okay, we're going to have different degrees between the numerator and denominator. And we have, in looking at the determination of the domain in the asymptotes, we have r of x equal to 3x cubed plus 5x. And if I go ahead and arrive at the domain, we have the denominator to be x squared minus 1, which cannot be equal to 0. And looking at what we have in factoring, okay, so you have with the difference of squares, so you have x plus 1 and x minus 1 cannot be 0. And we have the x plus 1 cannot be 0, nor can x minus 1 be equal to 0. So we have with exclusions from the domain, okay, we have that x cannot be negative or positive 1. So we have, for the domain, okay, we have at the lowest end, you have those values of x that will be less than negative 1, followed by those values of x that will be greater than negative 1 and less than 1. And for the rest of the domain, you have those values of x that will be greater than 1. Okay, now this rational expression is already in simplest form. Okay, there are no factors in the denominator. Okay, that will also be factors of the numerator. Now, we have in the numerator, okay, the highest order term, or the higher order term, we have a 3x cubed, and from the x cubed, we have the n is equal to 3. For the denominator, we have from x squared defines the degree of the denominator since that is the higher order term, so we have that n is equal to 3 and m is equal to 2. And from this, we have that n is greater than m by 1 degree. And if the numerator is greater than the denominator by 1 degree, okay, we're going to end up with a slant asymptote. And for what we have in the case of the slant asymptote, okay, that is going to be the quotient attained by taking the denominator x squared minus 1 into the divisor, which we will have at 3x cubed plus 5x. So in taking what we have in the process, okay, so I'm taking x squared minus 1 into 3x cubed plus 5x. Now, we're missing a square term, so I'm going to use 0 as a placeholder. And we have plus 5x. And the dividend, okay, has to conclude with a constant, so we'll use 0 for placeholder purposes. Now, for what we have as the first term in the quotient, so we have x squared into 3x cubed, or 3x cubed divided by x squared. So that's going to leave us with 3x. Now we have a 3x times x squared minus 1. Again, 3x over x squared will be 3x cubed. 3x over negative 1 is negative 3x. And if I apply these terms to the like terms from the dividend, so I have 3x cubed, and I have minus 3x. And taking what we have in the difference. So 3x cubed will go out, and there's nothing in x squared to bring down. And we have 5x minus negative 3x will be 5x plus 3x. So that is going to be at 8x. So we have from the long division, okay, so we have with the quotient is going to be a 3x. And we don't need the remainder, since I can, well, for one thing, I cannot take x squared directly into 8x, but your remainder would be at 8x. Okay, now the quotient is going to be at 3x, and that is going to define, okay, the slant asymptote. But let me, while I'm on this subject, okay, with polynomial division, now we would have as a statement, we have 3x cubed plus 5x divided by x squared minus 1. If I were to put this in quotient and remainder terms, Okay, we would have 3x cubed plus 5x over x squared minus 1. That would be equal to 3x. And we have plus 8x all over x squared minus 1. All right. Now, just going back to what we have in the overall picture. Again, we have with the domain, okay, again, negative and positive 1 were left out. Okay, so we have the domain on display. And now, for what we have, again, we had the slant asymptote. Okay, and you have, in this case, so we have with the quotient, so we have a 3x. So the slant asymptote, okay, we have at y is equal to 3x. And just to restate, again, so I have a slant asymptote at y is equal to 3x. And the domain we have exclusive of negative and positive 1. And since neither of these factors is a factor of the numerator, we're going to have with our vertical asymptotes, those exclusions from the domain are going to become our vertical asymptotes. So altogether, we have 3 asymptotes, 2 vertical asymptotes at x equals negative 1 and x equals 1, and we have a slant asymptote at y is equal to 3x.